So in order to start to look at stress as the three-dimensional tensor value that it is, we have to know how to get all the stresses and arrange them in a three-dimensional tensor. Usually what books do is they have these amorphous blobs with just random forces applied to it, and then we cut into them to see what stresses are acting on the inside. I think that's boring, so I came up with the character of Brotato. So notice Brotato looks awesome. He's got Venetian blind sunshades, a pop collar, and cool spiky hair. And then all these blobs has forces applied to it, but I wanted to make up a backstory for these forces. So what's happening here is Brotato has gone out to the bar, and all these lady potatoes really like him, and they all want to dance with him. So each force is actually a lady potato trying to pull Brotato in a different direction to dance with them. Since Brotato is being pulled in all these different directions, he's experiencing stresses on his insides. In order to analyze these stresses, we need to cut Brotato. Don't worry, this doesn't kill Brotato. It just allows Brotato to make new Brotatos, and thus propagating the species. So for instance, if we make a cut straight up and down through Brotato, you can put a little stress element, which is just a mathematical construct that represents a tiny portion of Brotato's material subjected to stress. And on that little element of Brotato, the stress element, you can find that there's going to be a normal stress and two shear stresses, one acting upwards, in this case in the y direction, one acting towards us in the z direction. And then the normal stress is always perpendicular to the surface. So you can arrange each one of those stresses into kind of a vector that contains the normal stress and two shear stresses on that face. You can repeat this process for the y normal plane and the z normal plane and see if you get something like this. Each one of those also has a normal stress. There's a y normal stress and two shear stresses in the z and x direction. And then for the front cut, there's a z normal stress and two shear stresses in the x and y direction. You can also arrange those into a vector representing all the stresses acting on that face.